Hey class, Mr. Moyden here with a example video on how to take a Riemann sum and write it as a definite integral. The main idea is that you have three parts to write in your answer. So a definite integral typically has the form as shown here. And the three parts to focus on are these limits of integration and then the function itself. So we need to figure out what those three parts are. The first thing I like to focus on is right here, because if you look at the definition of a definite integral, you'll see that that represents delta x. Moreover, we know that delta x is defined as b minus a over n. Actually, don't need to do this in color, so let me refrain from that. So delta x is b minus a over n. So in this particular case, delta x is 5 over n, which is to say that's also b minus a over n. And from the property of equality, you can see that 5 must equal b minus a. So this will be useful in just a moment. What that basically means is our interval space is 5 units wide. We're going from some number to some other number that's 5 more than it. That first number is actually very easy to find. It's what your index of your summation is starting from. So in this particular one, we have the limit as n approaches infinity of the summation from 0 up to n of the quantity 2 plus 5i over n, quantity squared, times 5 over n. Quite a mouthful there. We're starting at 2, and then we're adding, starting from 0, and then 1, and then 2, and then 3, etc., and then we're squaring that total, and then we're adding together all those squares. All of which is to say, this number right here, which is what we're starting with, is going to be our a. So our answer is starting to come into form. We have 2 of some function dx. Well, this 5 tells us then that if 5 is equal to b minus a, 5 is equal to b minus 2. Add 2 to both sides, and thus 7 is your b. So now we have most of our answer. This next part requires a little bit of a keen eye. You have to see that what you have here is a quantity, and this quantity represents inside here the argument, our variable, because that's what's going to change every time, and that variable is being squared. All of which is to say, this can be written as x squared. And there you go. This is the definite integral formation of this Riemann sum in sort of longhand form. Hope this helps.